Hey everyone, how's it going? Today we're going to be covering this very short tutorial, one of the most important concepts in AI, which is MCP. It is the go-to standard now for your AI model to connect with the rest of the internet in the world. And it does this by spinning up an MCP server that allows the AI model to know how to connect and how to use the data and tool that you've given it. And that data and tool you can basically create and make available to the AI model. So we'll be jumping into how to do that in this tutorial. The first thing I'm going to do is I have MCP open here, but as I have with my other tutorial that I've shown, is I'm going to be using the UV package installer. This is a Python installer that is 10 times faster than anything else. So that's what I'm going to be using for this tutorial, as well as I expect that you're going to have downloaded an IDE such as Cursor here. So I'm going to be using that here in order to create. So the first things first that I'm going to do is I'm going to create a new file, and I'm just going to call it mcp_server. So this is .py. So this is going to be our file, our Python file for creating the MCP server. Here I have the terminal open in the bottom, but you can also opening it up as an app. And the first thing that I'm going to do is I'm going to create a new environment. So with UV, which you can install according to the instructions here, you can do pip install UV in order to install UV if you don't have it already. So I'm going to do just pip install UV. And the other thing that I'll look at is creating a virtual environment. So I'm just going to look at venv here. And here you can see the instructions of how to create a virtual environment using UV. This is going to be a secure kind of environment where we can create different things and install specific packages. So I'm just going to write uvvenv underscore -- python 3.11, and I'll run that. And it'll create a secure environment for us to use. So it's not been able to find that. I'm just going to use uvvenv like that. And the only other thing that it'll say is you can activate it using this. So I'll paste that in, and there we go. I can tell it's been activated because of that, and it's created this folder. Cool. Now I need to install fastMCP. So if I go here and I write fastMCP, this is a open source project which allows you to very quickly create an MCP server, and it'll look a lot like a Fast API. So this is the instructions on how to do it, and I'm going to look for the pip installation. And here you see it already uses UV because this has become the most popular framework for installation. So you write UV pip install fastMCP. So I'll run that there. And you see it's very quickly downloaded all the dependencies I needed. Cool. So how do we actually create this MCP for server? I'm going to write from fastMCP import fastMCP. Surprise, surprise. So that is how you can get started. And it's as easy of creating an MCP server as you see here. You write MCP equals fastMCP. And then here we put, for example, a name. Let's call this the adder. So we'll maybe put a little emoji to do add, like that. Oh. So that's going to be the name of our MCP server. I'm just going to create a really simple one, which adds 2 numbers. So whenever an AI model calls this, it will add the 2 numbers that it gets from that AI model. So you can imagine that you do a separate function here, but I'm just going to write @mcp.tool. So it's going to be a tool that I make available, and you can customize this, but this is how an MCP server will work. And I'll define this as add. So it's going to be an add function. And I write a float. So this is just going to be the type, but here, just as you would in normal Python, you define the function, and I'm going to write float here as well. And the reason these are also important is that because you'll be telling the model how it's supposed to be able to, what it's supposed to give it. Because without this, it won't really know. And then I'm just going to simply do at the bottom here, return A plus B. And to get it up and running, it's going to be very similar to other API frameworks. but you can do if underscore underscore name underscore underscore equals main, like this. Then you do mcp.run. And there you go. That's how easy it is to create an MCP server. You import fastMCP, you create the MCP server, and then you define your tool. There's a bunch of other functionality that I won't show in this video, but if I here go and do Python 3, for example, or Python, should be fine, MCP server. Ooh. If I do Python MCP server like that, it should be able to get it up and running. And I think that's what it's doing right now. We're just not returning anything, right? So there we go. That's how we got it up and running, and you can see it works. Now, how do we call this MCP server? So I am a big fan of the Mistral models. So I'm going to be creating a new file. Now that we create this MCP server, you also have to have a model that calls it. So here, I'm just going to write Mistral client.py. And so that's what I'm going to be calling the models with. I'm going to just write a couple of imports. So in async IO, import JSON, import sys, import sys, import OS, import .env. So this is what I'm going to use. Load.env. I'm going to from fast MCP import fast MCP. Oh no, I'm going to import client as MCP client. I'm also going to do from Mistral AI import Mistral. This is wrong. And I'm going to write from MCP server, which I have defined here, import MCP as server underscore MCP. So a bunch of imports that we've done there, but this will help ensure that we have everything we need. So I'm going to also do a uv pip install Mistral AI. And I'm going to need that package, and I'm going to also import .env, so python.env. So I'll just write uv pip install python.env. Cool. The first thing I'm going to do is I'm going to write load.env. And here I'll create a .env file, and I'll show you later when I do it, but I'm going to create an API key. So I'm going to write API key equals os.getEnd Mistral API key. So I'll just put that into here like that. And I'll do model that I'll use is Mistral small latest. So this is one of the fast models and smaller models that Mistral has. And I'll write tools equals, I'll just write a couple of tools. So here I'll just define the add function. So I'll write type function. And I can write out the function here. So I'll write here function, and then here it's pretty much summarized everything, but you can write, for example, a name, a description, parameters, and just in terms of parameters, I'll do an object here, but I'll also add properties like this, and it'll be type A and B, which are numbers, and they're required. So that is how I define the tool call that will pass to the LLM. And I'll create a main function now. So async definition main, and it takes in a float on both sides, and with nothing returned. And we'll just create here an MCP server, async with MCP client, server MCP as client. Well, we'll write here as MCP. And then we'll write client equals Mistral. So that's the Mistral client. We'll define the API key, the model, and the tools. So this is exactly the format that we're being asked. Actually, model you don't define here in tools as well. So we just define the client. And we'll write messages equals, and we'll write a user message saying, what is A plus B? So we can write here, what is A plus B? And here in terms of the response, we'll do response equals await. Well, we'll just do client dot chat dot completions dot complete, I think it is. Client dot chat dot complete, and here we'll pass the model, we'll pass the messages, we'll pass the tools, we'll pass the tool choice, we'll do any, and here we will also allow parallel tool calls, even though it's probably not needed here. We'll then write call equals response dot choices. So this means that once the model responds, we'll get the first message back. And we'll also fetch the arguments. So here, when someone gives a certain argument, so what is A plus B, or when someone gives an argument, we'll basically wait to hear back, and then we'll load the response. So the user here, we're mocking that they're asking what A plus B is. And here we'll mock what that is. But here, I'll just write here, for example, 3 for the time being. And here I'll do 5 for the time being, so as defaults, because we're just using this to simulate what it's like. And here in the args, you do json.loads call.function.argument, arguments, and then MCP response is going to equal await MCP dot call underscore tool add, and then args, like this. And so if I do messages dot append, so I'm going to add one more message, and I'm going to add a tool call message. And the way that I do that is you can do, for example, like this. So we've opened the brackets here. And we'll do, instead of here, role tool, and the content. So we'll include the response that the model has given here, which is the response.choices.message, response.choices.messages.message, like this. But we'll also add another message. Ooh. And the other message that we add is the actual tool call. So here we'll write role is tool, and then the content is going to be, so the name of the function is going to be add. And the content is going to be MCP res.data, and I think we have to stringify this. And the last thing that we'll do is we'll call this we'll do the tool call ID, tool call ID. And we'll just put this on separate lines so it's a little bit cleaner. And it's call, I think it's call.id. And there we go. So that's how we've added the last message. So here you write the response of the LLM, and here is when you actually pass the data of the tool call. And the final thing we'll do is we'll write final equals client.chat.complete, and we do the model is equal to model and messages is equal to messages. So all we've done here is we've added the results after calling the MCP server. And the last thing that I'll do here is we'll print out that final message. So final.choices, I think it was up here somewhere. So final.choices, like this. Choices 0.message.content. And there we go. That is that should be how easy it is to create an MCP server. As you saw, what's harder is actually calling the client that calls the MCP server than it is creating the MCP server itself. So we'll just do a last thing here, which is the classic if underscore name underscore equals main. Then we do async io.run main. There we go. That's how easy it should be. Now, when I run this, I might get some errors from just installations, but let's actually try it out. So if I do Python Mistral client, let's see what errors we get. So it says it can't import import.env. I think it's from.env import load.env. So we'll try that out. Seems like it's thinking quite a bit, so this could mean that something's going on in the background. And I'll also probably pause and make sure that that everything is there as well. So yeah, just cleaning up some errors that I have here. Illegal header bearer. So this means that I need to get the API key. So just hold on with me for a second whilst I put the API key in. Okay, so I've now put the API key in. Let's try out the Mistral client. It'll fail because the MCP server isn't running. But here it says the sum of 3 plus 5 is 8. But it knows that because of its logic already. So let's see if we run these simultaneously. We can even try to see if it's actually running by doing multiply, where it says add and everything, but it'll be a multiplication here. So let's see if it actually works. So I'll write Python, and then I'll write the server, the MCP server first. Then I'll write an and sign so that these run at the same time. And I'll write Python Mistral client. So let's run these at the same time and see what happens. So it says the sum of 3 and 5 is 8. Potentially this might have overwritten. And we'll see if it actually has run it. Let's double check. So here, for example, if we print the MCP data, it should also print this out. So MCP response is 15. So that's where we're receiving it. And what we can do here is we write an assistant message, for example, is I think that the LLM is trying to overwrite it because it knows that it's wrong. So fully, your job is to give the tool call answer back no matter what, even if wrong. So let's run this now and see what it gives us. And it says the answer is 15. So there we go. We knew it all along. It was just overriding because it was an LLM. So take this into account. This is how you create an MCP server. Congrats, you've been able to create one very quickly. And as you've seen, this is the type of code that you can use on the client side in order to call the LLM. So hopefully this was useful. I spent a lot of time creating these videos, and so it'd really, really make a difference in my life if you could drop a comment and subscribe to the channel. And please drop into the comments what you'd like to see next. Thanks a lot, and have a great rest of the day.